Good afternoon. We are Team Prometeo, Group TI-81 from the Technological University of the Riviera Maya. Today we are going to present our final project for the Professional Web Development course corresponding to Unit 3 Security for User Roles. Project is called Prometeo and it's a full stack web application that we developed as a team of 8 people over a 3-week period. The main objective was to build a robust authentication and authorization system that handles different access levels securely public user and administrator. In this presentation, we are going to show you step by step how we planned, developed, tested, and deployed this project. And at the end, we'll do a live demonstration of the application running in production.
Before writing a single line of code, we sat down as a team to fully understand what was being asked in assignment. We used the Scalidor tool to sketch out the entire project structure visual. We divide the application into 3 access levels: public, user, and administrator. For the public part, we plan the login, the sign-up, and the password recovery flow. For the user part, we define a main dashboard, an active sessions section, and the user profile. For the administrator part, we added a dashboard with the system monitoring and the administrator profile. This planning was a key because it allowed us to define the routes, permissions, and folder structure we would need from the very beginning before touching any code. This saved us a lot of time during development because we already knew exist what the build and how the pieces will connect.
Prometeo is a full-stack application developed mainly with JavaScript, following a client-server architecture. On the front end, we use React to build interface through usable components. Byte as our development and build tool for its bits. Tag with CSS for responsive design. React Router for client-side navigation without providing the page. And Lucid React for a consistent icon library throughout the app. On the backend, we worked with Node.js and Express to build our REST API. For security, we used bcrypt to encrypt passwords, JSON with tokens for authentication and authorization, and Helmet together with Cores to protect the API from common vulnerabilities. For database, we choose MongoDB and NoSQL database, along with Mongo's as our data modeling layer. And as additional tools, we use Resend and Reg email to send password recovery emails, and PMPM workspace to manage our monorepo in a centralization way.
Our project is organized as a monorepo within a single GitHub repository. This means the frontend and backend live together but are completely separated in their logic. First, the frontend folder contains the entire React interface, page, routes, and the services that communicate with the API. For the other side, the backend folders contains our Express API with controllers, models, and all the business logic. And at the root of the project, we have the configuration files, dependencies, and documentation. We use GitHub for version control and team collaboration, working with branches and pull requests, so that each new feature was reviewed before being merged into the main branch. For deployment, we choose DigitalOcean App Platform because it integrates directly with GitHub, simplifies the deployment process, gives us access to real-time logs, and securely manage our environment variables. Finally, the database remains hosted separately on MongoDB Atlas.
Our database is called Prometeo and runs inside a MongoDB Atlas cluster called Prometeo Cluster. We manage it visually with MongoDB Compass. We designed a scheme around 3 main collections that work together. The user collection, where we centralize account information, names, emails, password protects through bcrypt encryption, and each user role, administrator or regular user. For testing and demo purpose, we use a PNPM script that let us quickly populate the database with predefined accounts. The tokens collection, which is fundamental to our security system. Every time a user logs in, a token is generated and recorded here. along with the device IP address when it expires and whether it has been revoked or not. This collection grows dynamically as the system is used, and the system logs collection, which function as our audit trail. Here we record every successful login, every file attempt, and the status of the device connections, with their severity level and exact timestamp, allowing real-time system monitoring. The structure let us control access, monitor activity, and keep the platform secure at all times. Prometheus interface is built with React, designed to be clean, responsive, and easy to navigate on both desktop and mobile devices. The application covers five main areas: the authentication module with login, sign-up, and password recovery with real-time validation; the main dashboard, which is the central point where the user sees state account status; the monitoring module, exclusive to administrator with session diagnostics; the active sessions sections, where the user can view and revoke device connected to their account; and the profiles, where personal information is managed. Each of these screens was designed around the three access levels we planned from the start: public, user, and administrator.
Well, the pre-testing to ensure the stability, functionality, and security of Prometeo, we carry out a complete testing process on our API. We used Postman to simulate real HTTP requests and browser developer tools to audit how the frontend and backend communicate. Our tests focus on three fundamental pillars. First, authentication and JWT. We test login and registrations with valid and invalid credentials, confirming that the token is issued correctly and the invalid attempts return the corresponding error codes 401 or 400. Second, role-based access control RBAC. We test admin excludes endpoints using a regular user token and confirm that the system correctly responds with a 4003 for providing error. When repeating the test with an administrator tokens, the request was processed successfully with a 200 error handling. We intentionally send requests with incomplete data and verify that the system never crashes, but instance respond with clear, standardized error message that the frontend can interpret. Well, the next slide is project deployment. Prometeo is deployed in production using the DigitalOcean App Platform with a monorepo approach where the frontend and backend live under the same infrastructure and domain calling galetis.lat. The backend runs as a web service on port 3000. The frontend is deployed as a static site with a special configuration so that read routes work correctly even when the page is refreshed. We configured a custom domain with an ASL certificate through DigitalOcean, including the DNS records needed for our email service to work in production. We also have a CI and CD pipeline running every time we push code to the main branch on GitHub. A new deployment is created automatically with no manual steps required. The application is fully functional right now, and you can access it at https://galactics.latdocs. Next, we are going to show you the project working live.
Now we are going to switch to real application already deployed in production to show you how it works under the hood. First, I want to explain a key architectural decision. Do we use stateful or stateless sessions? The answer is that we implement a hybrid model. We use JSON Web Tokens, which are inherently stateless, meaning the server doesn't need to store the token in memory to validate it. It simply verifies its signature. This gives us speed and scalability because any instance of our backend can validate the token without needing to query a shared database on every request. However, a pure JWT has an import limitation. Once issued, it cannot be revoked before it expires, and for us, being able to log out or remote device immediately was an essential security requirement. That's why we decided to combine it with a stateful component. Every token which issue is also recorded in our tokens collection in MongoDB. We store the device, the browser, the operating system, the IP address, the creation date, the expiration date, the last activity, and above all, a boolean. Field called revoked. Every time requires a reverse in addition to validating the JWT signature, we check in the database that a specific token hasn't been marked as revoked. Why did we design the database this way? Because we needed to track active tokens per user, allow the user to see which device have an open the sessions, and give them the ability to revoke any of those sessions manually and immediately. This design also gives us control over duration. Our access tokens last 15 minutes and refresh tokens last 60 days, but they can be revoked at any time from the tokens collection, regardless of their remaining lifetime. In summary, we take advantage of the speed of the stateless model for a normal validation, but with add stateful user exclusive for session control and revocation, which is where centralized control really matters.
I talking about two very specific security decisions we implement in Prometeo: vulnerabilities defense analysis. First, protection against user enumeration in password recovery. User enumeration is a very common vulnerability. It occurs when a attacker can figure out which email and register in the system simple by observing the server's response. For example, if when requesting a password reset, the system responds, "This email doesn't exist," when the email isn't registered, and when send you a link, we send you a link. When is the attacker can use the difference to build a list of validated emails, which is a common preliminary step for brute force attacks or target phishing. Or password recovery follow completely eliminates these three because regardless of whether the entry emails exist in an or database or not, the system always responds with exactly the same message. If the email exists when say you are recovering a link, the server's behavior is identical in both cases in response time and in the message shown, making it possible for a attacker to difference between a registered email and on that isn't. Internally, the system only sends the actual email if the account exists, but the response to the client never reveals that information. Second, protected refresh tokens through HTTP online cookies. In most application sections, tokens are usually stored in the browser local storage or local storage, which makes the vulnerability to XSS cross-site scripting attacks, where injected malicious script could steal them. In Prometeo, we decide to raise the security level by handling our section into pass. The short-line access token is handled by the client, but the refresh token, which is critical because it has a long lifespan and allows generation new access token, it's never accessible to the front codec. From the server, we configured it both be sent exclusively as HTTP cookie with the HTTP online security in production and save the flags. This means the software we automatically send to the token with every renewable request to the server, but it's impossible for malicious JavaScript code to read or intercept in front of the client. This measure drastically closed the door to present section defect.
Now we are going to demonstrate in real time three execution scenarios that validate everything we just explained. We are going to open two different browser windows. You can see I have a normal window and another one in incognito mode to simulate two different devices. I'm going to log in with the same user account in both windows. As you can see, both logins were successful. Now, I'm going to go to the activity sessions section for either window. Here you can see how both sessions appear dynamically, each with its browser, its operating system, its IP address, and the time of the last activity. This confirms that our tokens collection is correctly recording each sessions independently, just as we explained in the editor overview.
Now we are going to demonstrate real-time section recovery. I'm going to call the normal window section A and incognito window section B in different navigation. From the section B, I'm going to go to the active section, list and the quit of section A by clicking the record button next to the device. Perfect, the system confirms that the section was recovered. Now we are going to go back to section A, which still has the page open. We are going to integrate with the dashboard. For example, I will try to navigate to another section or reload the page. As you can see, the section A is in modality blocky on its next interaction. It's automatically directed to login screen. This happens because, as we explained before, every request validates not only the JWT signature, but also the token's status in our database by marking its a recovery value true. Any sequence request from the devices immediately reject without needing to wait for the token to expire naturally. Finally, we are going to test our role-based access control. I'm going to log in with a regular user account. It's a account the user with role user. We have administrator permits. It's a use the account a different role. It's a admin role. Now we did basically use the token. I'm going to try to access the email console directly by manually navigate to route admin or dashboard admin or different route. Only permit its access admin, account the admin, re-roll. And as you can see, the system clearly intercept the request and shows use HTTP 403 forward row, clearly indicate that we don't have permission to access this result. The interface doesn't break or show central backend information and simply informs use the access it's denied. Is this stands or authorized role middleware, which the checks to role contained in the token before allowing the corresponding control to execute. If we repeat this exact same the test with the administrator token, the request will be processed successfully.
Demonstration, we are going to do a quick walkthrough of the application's main modules, showing the complete flow from login to the system logs panel. First, I'm going to log in a regular user account. Once inside, the user sees their main dashboard with their current role, their activity sessions, and their last access. From the side menu, they can navigate to active sessions where they review and control their connected device, and to profile where they can update their personal information and email address. Now I'm going to log out and log in an administrator account. As you can see, the administrator has access to the same general sections, dashboard, active sessions, and profile, but they also have an exclusive section called system logs, which only appears in the menu because this account role is admin. This is where the entire audit trail we mentioned before is reflected. Every successful login, every file attempt, the status of the database connections, and with their severity and timestamp. This is the system logs collection that lives in MongoDB, displayed clearly and in an organized way so the administrator can monitor the system health and security in real time.
With this, we conclude the Prometeo presentation. This project allows us to practically apply everything we learned about secure backend architecture and the integration of multiple technologies within a single ecosystem. As a team, we managed to implement a multi-session management system with remote device control and revocation, a password recovery flow that eliminates common vulnerabilities such as user enumeration and role-based authentication and authorization middleware that ensures each user only access what they entitled to. This project strengthens our knowledge in developing secure, scalable web applications and allows us to work collaboratively, solving technical challenges similar to those we will face in a real production environment. Thank you very much for your attention. We are Team Prometeo Group TI 81.